NASA and AeroJet Rocketdyne have announced the successful test firing of RS-25 rocket engine with 3D printed components. The innovative engine is being built to power NASA's Space Launch System, SLS, which is expected to send a team of astronauts to an area near the Moon as soon as 2020. The hot firing test took place recently at NASA's Stennis Space Center in Mississippi and consisted of firing the RS-25 engine for 365 seconds. According to NASA and AeroJet Rocketdyne, which developed the partially 3D printed engine, the hot fire test enabled them to qualify the controller for the third of 4 RS-25 engines that will power the SLS first stage on Exploration Mission 2, also known as EM2. This mission will be a particularly significant one as it will be the first in almost 50 years to send a human beyond low Earth orbit. AeroJet Rocketdyne is playing a vital role in the nation's effort to expand the frontiers of humankind, commented Eileen Drake, AeroJet Rocketdyne's CEO and president. This test is the latest example of our steady progress, not only toward EM2 but also toward putting the nation's exploration program on a sustainable path for the future. Notably, the hot fire testing showcased the efficiency of one of the RS-25 engine's 3D printed components, the pogo accumulator assembly. This 3D printed part is designed to reduce engine vibrations during flight which could cause instability. So far, the 3D printed component has been tested in the engine twice and has shown promising performances. Though the pogo accumulator assembly is the engine's largest 3D printed component, it is not its only one, as AeroJet Rocketdyne is increasingly turning to additive manufacturing technology to create complex and lower-cost parts. In fact, the company says that it plans to reduce overall manufacturing costs for the RS-25 engine by up to 30% by integrating more 3D printed parts. We ended 2017 with a successful engine test in December and have now maintained that momentum into 2018, said Dan Adamski, RS-25 Program Director at AeroJet Rocketdyne. Future testing this year will continue to add to the program's inventory of flight controllers and will bring additional development hardware into the test program to demonstrate design, manufacturing and affordability improvements. Our pogo accumulator assembly is just one of the first of these efforts to be hot fire tested. Currently, the RS-25 program consists of 16 legacy engines, which are based on NASA's Space Shuttle main engine design. These existing engines are going through an upgrading process which will see their thrust increased from 491,000 pounds to 512,000 pounds, and which will integrate smaller and powerful controller systems. The engine upgrades will also include some redesigning and simplification which is largely enabled thanks to 3D modeling and 3D printing. Additive manufacturing will also help to increase the affordability and sustainability of manufacturing rocket engines, says AeroJet Rocketdyne. While the first crewed SLS missions are expected to take place in the early 2020s, NASA and AeroJet Rocketdyne are already preparing to send an SLS mission to space with an uncrewed version of NASA's Orion spacecraft in 2019.